Hi everyone, welcome to video 11-1. We're going to be talking about dilations today, and just congratulations on us getting halfway through this book. This is great. So we're going to continue talking about our lesson on our chapter on similarity by talking about a dilation. Now, a dilation is a transformation, as you can see here in the definition, a transformation that changes the size of a polygon but leaves the shape unchanged. So that means it gets bigger or smaller, but it doesn't distort the shape of the image at all. Two kind of vocabulary words associated with dilation. It has a center of dilation and a scale factor. So those two things together kind of determine after the dilation happens where the image is going to end up. Okay, that's really all we needed to go over on this page. So this is page 577 that we're on right now, and we're going to flip ahead to page 579. Alright, on page 579 here we are with Explain 1, and we're just going to be talking about applying properties of dilations. The center of a dilation is the fixed point about which all the other points are transformed when you're doing a dilation. So it's the one that doesn't move. The ratio of the lengths of the corresponding sides in the image and the pre-image is called the scale factor. So when we think of, again, it should be image to pre-image is the ratio there. And that's a fraction you just need to keep in mind is always going to have the image in the numerator and the pre-image in the denominator. Okay, so this is what a dilation does, or this is what we can expect if it is a dilation for all these things here in this box to be true. First off, a dilation is going to preserve the angle measure of the figure. So again, it's not going to change shape. That's the angle that determines the shape. The dilation is going to preserve betweenness and collinearity. Basically, that just means if I were to put a point on the pre-image in between 2 points, then in the image, that same point's image would be between those 2 points. So it's kind of just a description of keeping a line segment, basically. Dilations preserve orientation, so that means it doesn't flip. You don't see a reflection happening. And then dilations map a line segment to another line segment whose length is the product of the scale factor and then the length of the pre-image. So that's really important to remember there, that it's the product of the scale factor once we actually start mapping the dilations. Again, here all we're doing in this Explain 1 is talking about is it a dilation or not. Okay, so let's move through example 1 here. We're going to determine if the transformation on the coordinate plane is a dilation, and if it is, we're going to give the scale factor. So example 1, you can see that we are preserving angle measure. We've got parallelogram over here and parallelogram over here, so yes, angles are staying the same, and you can verify that by putting on a protractor if you want to. Betweenness and collinearity, sure. Preserves orientation, though, we have a big fat no here. So as soon as we get a no, we can actually go straight to a no answer overall. It is not a dilation. But just in case you were wondering, the ratio of the corresponding sides is 1 to 1. Don't let that confuse you. That would have been true for a congruence transformation, but if we get a no, then we go straight to it being a no, it's not a dilation. So let's see in part B here if we can fill in what we need. Does this preserve angle measure over between the pre-image and the image? And if we were to put a protractor down there, I think we would agree that that is a yes. Does it preserve betweenness and collinearity? Again, if I were to put a point on the pre-image and then on the image, would it stay between the two? Would it stay on the line? Yes, it would. Question is, can I preserve its orientation? In other words, can I go clockwise and encounter the points in the same way, or counterclockwise? So counterclockwise, if I go A to B then C, then the same thing is true counterclockwise, A prime to B prime to C prime. So orientation in this case is staying the same. The question is, what is the scale factor? And that is, hopefully you can see that the lines themselves, the line segments themselves, are double the length. So we have a run of 3 and a rise of 1 here from A to B, and this is a run of 6 and a rise of 2. So the scale factor in this case is 2 to 1. And then the final question is this transformation a dilation? Well, if we look at our questions, we have not gotten a no, so we are saying yes, this one is a dilation. All right, let's look on the next page. So I'm here on page 580, and here's where you're going to be doing your turns. Keep in mind the questions that we asked ourselves about the dilations that we see in front of us on the previous page, and go through kind of question by question. That's why you have so many lines next to each one here, and determine whether it's a dilation or not. So pause the video here before we go on to the next part. Okay, moving on to the next part, we have explain to, which is where we're going to be determining where the center of a dilation is occurring. So between the pre-image and the image, are we able to map back to kind of a point of origin, or what we call the center of dilation? So the process here is that we're going to draw lines between a pre-image and an image point pairing, and you're going to have 3 of those. So here's the line that goes between A and A prime, and you want to extend it back the direction where you think it was originating from. And then again, between B prime and B, and C prime and C. Make sure you're connecting the points of the actual vertices of the triangle so that you can come back to one point of origin, and we're going to call that O. And then what we're going to do now that we've determined the location of the center of dilation, to determine the scale factor, what we're going to do is to measure each of the segments. So you can see that we're going from O to A originally, and then from O to A prime. And you can see that we've gone from 25 to 50 millimeters. Then we go from O to B, which is 13 millimeters, and then from O all the way out to B prime, and that's 26. And then from O out to C, but then from O out to C prime. So again, always originating at the O, which is the origin or the center of dilation. And then you can see that if we look at the pairings of those numbers, 25 to 50, 13 becomes 26, and 19 becomes 38. Just a reminder again, the scale factor is always the ratio with the image on top and the pre-image on the bottom. So the image are the prime points, remember? So in this case we would have 50 over 25, which is where we get that 2 to 1. On the next page, continuing this idea here, we're going to take our ruler and we're going to draw some lines in, and we're going to find the point of intersection of the lines between A prime, B prime, and C prime. And then after we find that point of origin, we're going to measure out to the nearest millimeter, what you can see in the instructions there, to find the scale factor. Okay, you can see the 3 lines that I've drawn on here, and we've got then our point of origin is back here, point 0 is, or point O is the center of dilation. And then what we're going to do is we're going to measure each segment. Again, remember, from O out to the original pre-image point A, and then from O out to the image point A prime. We're going to fill in those values. Let's just take your straight edge for a second, or your ruler, and put in the values there. These are what I get. 60. These are all millimeters, so I'll just keep with numbers versus units just for a quick second. So millimeters goes all the way down. And the scale factor, remember, is the ratio of image to pre-image. So in this case, that's 30 to 60, or 19 to 38, or 26 to 52. And I think you would agree that that is going to be a scale factor ratio of 1/2. And you can see that between the pre-image, big triangle here, and image triangle, it gets smaller. So we would expect the scale factor to be something less than 1. Alright, in the your turn coming up here on this page, you're going to determine the center of dilation and the scale factor, same exact way that we did. Looks like they've already drawn for you the lines, so that's convenient, and all you have to do is do just one set of measurements it's looking for there, between O to A prime and O to A, and then getting the ratio. So they've actually done the hard work for you on that one. You didn't even have to draw any lines. Okay. And that's the end of our Explain 1 and 2 in our video here about dilations. And go ahead and work on the evaluates that are on your outline now.